Okay, so now we have the next problem here, which is same tree. Easy problem from the trees category, and the problem states that we have given the roots of two binary trees, okay, P and Q. So the statement is, given the roots of two binary trees P and Q, write a function to check if they are the same or not. Now you have two roots, P and Q. Two binary trees are considered the same if they are structured identical and the nodes have the same values. So that's what it says, like if it's 1, 2, and 3, 1, 2, and 3, P is 1, 2, and 3, and Q is 1, 2, 3, so we have true as the output. Example 2, we have 1, 2, and then we have null. And then over here, 1, null, and then 2. So 1, 2, and then 1, 2, and then null, we don't have to mention it. But if we have 1 and then null and then 2, we could mention it like this. So this is false because they're not identical at all. And then we have the last one, which is 1, 2, 1, and then we have 1, 1, 2. But these values are different, so 1, 2, 1, and then we have 1, 1, 2, so this is a false, so these are not identical either. We have to find same trees with the same node structure as well as the values. So the constraints here, the number of nodes in both trees is in the range from 0 to 100, the number of nodes, and then the value is in between minus 10 raised to the power 4 all the way to 10 raised to the power 4. So let's go and complete this up. So we have the definition of a binary tree node. So we have a struct tree node, which is in value, we have a pointer to left, pointer to right, and then we have tree node value 0. We have left null pointer, right null pointer. Then we have tree node in X. We have value X. We have left null pointer, right null pointer. So again, we have tree node in X, left, right, we have value X, left, left, and then we're right. So this is pretty similar, it's pretty same. So in val, tree node pointer left, tree node pointer right, and then the same exact stuff that I'm talking about last. These are constructor 1, constructor 2. This is a default constructor, this is a parameterized constructor, this is also a parameterized constructor. Okay, look, the solution is that we have two pointers. This is the tree node pointer P and then tree node pointer Q. And we need to find if both of them are similar or not. Again, this problem is kind of like whenever you're talking about trees, you kind of have to do recursion because you have to go to each sub-level. And whenever, like I said, like we break it up, we think of recursion at first, and then we can also think of the base case. So okay, so what could be the base case? Just like how normally everything we talk about, if we're null pointers or like nothing, then we could just return, that they're identical because they're null. So what I gotta do is if the P root node is equal to a null pointer and the Q is equal to a null pointer, okay, then I simply could have the return as true because both of them are the same, right? Null pointer meaning that there's no such tree, okay? After that, when we have them like the same, so if I have another case when I say if P is equal to a null pointer or Q is equal to null pointer, this means that either one of them is a null pointer. Then we could have this as false. I'll tell you the reason why I'm saying this. So let me just clarify the things. This is a Boolean return type. So over here, if both of them are null, that means you could safely return true, like there's nothing, like null null. But if it's like one is null and the other is not, or if P is null and the Q is not, or or P is not null and Q is null, then we return false because they're not matching. They have to be the same, exactly the same. The next thing we could do is we have to check like if they're exactly the same, right? So we have to check the same solution here. We go, remember like how we use recursion, we have to check the same for the left subchild and right subchild. So is same, tree, and then we have the P's left child, so P left, okay, and then we have Q's left, and then we have to do the same for the right one. So I'm gonna have to put an ampersand here, and I say is same tree P's right, and then we have Q right. Okay. So when we have all of this specified, we have is same tree both sides if they're all true. So what we're gonna do is we're gonna have to return something. We have to return the value. So we have the return p hyphen value, and then we have is equal to q hyphen value. We have to check if they're the same, right? The only way we could specify this, if they're same is like if both values are equal, then we could actually have this ampersand. Now I'll tell you how this works. We have this ampersand operator. This means that all of this stuff has to be true. This values have to be true. The left have to be the same. The rights have to be the same. So same, same, same. Otherwise it will just go false. Any case. And it will just keep checking until it finds everything as true. It's going to return this as true, because normally you'll go all the way to the end and then you'll have null and you'll just return true, true, true. So basically that's exactly what it's saying. That's how recursion works. And it determines whether these two things are true or false. This will also return true because the values are true, so it might at the end of the day it would return true. So let's have this control and comma and see if this actually is the solution. Okay, so we have a compile issue over here, and let's see, look at what it is. So we have error line number 23, character 20. So line number 23, which is right this one, which is also like highlighted. Error, no member named value in tree. Okay, so no member named value. If you look over here, we have val, not value. So what we have is we have to change it to val, like this and this, and then we have control and comma. Okay, now I accidentally commented out the return statement. What? So basically I ran it first and then I commented the return statement out. So let me just uncomment this and just rerun it again. It ran because I first ran it and then commented it. So let me just do that, and now control and comma. It should accept all the test cases. So yep, we have 1, 2, and 3 p, and q is 1, 2, and 3. Then we have output as true, expected is true. Perfect. The same goes for case 2. We have 1, 2, and then we have q is 1 null, and then we have 2, and then over here we have false, and expected is false. Awesome. And the last one, these are all these examples, 1, 2, and 1, and 1, 1, 2. This should be false, and then output is false, expected is false. Great job. This is a really amazing solution. Again, you can just double check the explanation here and say explain the following in simple words. So this code is checking for 2 binary trees. If 2 binary trees are exactly the same, meaning they have the same what? The same structure and the same values in each corresponding node. Okay? Now here's how it works. We have a function called isSameTree that takes 2 tree node pointers, p and q, as input. These represent the roots of the 2 trees we want to compare. First, it checks if both p and q are null pointers. If they are, it means both trees are empty. Okay? So they are the same. In this case, the function returns true. So over here we have checks if both p and q are null pointers. If they are, it means both trees are empty. So they are the same. Basically, over here we have it checks if both p and q are null pointers. Okay, if p is null and q is null. If they are, it means both trees are empty, so they are the same. In this case, the function returns true. That was our first base case, if you remember right here. Okay? not here, which this is not this one, so right here. Okay, and then we have the next one, check. So then it checks either P or Q is a null pointer, but not both. If that's the case, it means one tree is empty while the other is not, so they can't be the same. In this case, the function returns false. Again, this was the second check, which is right here. The last one, which is this one. So if neither P or Q is null, okay, nor Q is null, it compares the values of their current nodes. If the values are different, the trees can't be the same, so it returns false. So basically over here, it just checks each value of the node. If the values of the current nodes are the same, it recursively checks if the left subtrees of P and Q are the same. And also recursively checks if the right subtrees of P and Q are the same. So basically, if the values are correct, then it recursively checks the left subtrees and recursively checks the right subtrees of each node. Okay, left, P, and Q. Finally, it returns true only if the values of the current nodes are the same, and both the left and right subtrees of P and Q are also the same. So it returns only when the values of the current nodes are the same and both the left and right subtrees of P and Q are also the same. So in simpler terms, the function compares two trees node by node. It checks if both trees are empty or if only one is empty. If neither is empty, it checks if the current nodes have the same value, and then recursively checks if their left and right subtrees are also the same. If all these conditions are met, it concludes that those trees are the same. So it generally goes here, like suppose we have 1, 1, and then we have 2 and 2, and then we have right 3 and 3. So it basically checks like this: 1, 1, same. Let's go on the left side. So 2, 2, same. Let's go on the right side. 3 and 3, same. And then we return true. Now I hope you got this solution, and pretty much that's how we submit it. So we basically have now Control and Enter to submit the solution, and this is accepted. So really great, really good solution. Alrighty, so stay tuned for the next one.